In this video, I'm going to discuss some very basic functions that are called the library of functions. These are functions that you're already familiar with, and we're going to talk about how to graph them. It is very important that you memorize the graphs of these functions. The first function in our library is the function x squared. I want you to pause this video for a minute and fill in the table of values. For example, what is -2 quantity squared, -1 quantity squared, and so forth. So if you have completed that basic table of values, this is what you're going to get. At 0, the function is 0. 1 squared is 1. 2 squared is 4. -2 squared is also 4, and so forth. So let's try to think about how we're going to memorize the graph of x squared. It decreases on the left of 0. It's decreasing from -infinity to 0. It's increasing from 0 to infinity. It has a local and absolute minimum at 0, 0. It is U-shaped. The next graph in our library of functions is x cubed. Take a moment to pause this video and fill in the table of values. For example, -2 quantity cubed is -8. -1 quantity cubed is -1. So this is what we get when we graph x cubed. The point 0, 0 is included. If we're trying to describe the shape and memorize the shape, it is a strictly increasing function. It does have a change in what I'm going to call curvature at 0, 0. To the right of 0, 0, it is curved up, shaped up. We're going to call that concave up. To the left of 0, 0, it is shaped down. We're going to call that concave down. This point 0, 0, 0, 0 is neither a local max or min. We call it an inflection point. It is the point where it changes its shape or its curvature, where it goes from being curved down, concave down, to being shaped up, concave up. The next function in our library of functions is the square root of x. The square root of -9 and -4 and -1 are undefined. They will not appear on our graph. The square root of 0 and 1 and 4 and 3 and 9 are well known. So take a moment again to fill in the table, pause, and go to the next slide. So the graph of the square root of x has a restricted domain. The negative numbers are not part of the domain. The function begins at 0, 0 and includes all positive real numbers. So the domain is square bracket 0 to infinity. It is an increasing function. It does have some curvature. It is actually curved down. It is not a straight line. The next function in our library is the cube root of x. The cube root of -8 is actually -2. The cube root of -1 is -1. The cube root of 0 is 0. And the cube root of 1 is 1. And the cube root of 8 is 2. So pause the video, make a table, and then proceed. So using our values from the table, this is what we get for the graph of the cube root of x. The cube root of x, again, has a change in curvature occurring at 0, 0. It is another strictly increasing function. The domain and range are all real numbers. How do you distinguish this graph from x cubed? X cubed was concave up in the first quadrant. The cube root is concave down in the first quadrant. X cubed was concave down in the third quadrant. The cube root is concave up in the third quadrant. You need to memorize this graph. The last graph in our library of functions is the absolute value of x. The absolute value of -2 is +2. Of -1 is +1. Of 0 is 1. And of 1 it's 1. And of 2 it's 2. This is the graph. What is the essential difference between the graph of x squared and the graph of the absolute value of x? X squared has some curvature. X squared is curved, nonlinear on the left. X squared is curved, nonlinear on the right. Absolute value of x is a straight line on the left and a straight line on the right. I need you to memorize these graphs because the next thing we're going to do is transform them, and you can't transform them unless you're familiar with them.